Beneath the surface of Geneva, under the Earth's crust, lies a monument to human creativity, and a potential signal of catastrophe: the colossal Hadron Collider. This sophisticated tool allows researchers to investigate the subatomic realm and aids in the quest to uncover the mysterious God particle. In recent years, renowned physicist Brian Cox made an astonishing declaration that sent waves through the scientific world. A surprising discovery at CERN could have implications that far exceed our current comprehension. Have we set ourselves on a collision course with disaster in our pursuit of understanding? Join us as we unravel this perplexing enigma. But before we explore the details of this breakthrough, first, let's understand the idea of a particle accelerator. The Large Hadron Collider, LHC, operated by CERN, is a 17-mile ring of superconducting magnets, the most potent particle accelerator worldwide. It serves as the apex of human scientific accomplishment, capable of recreating the conditions at the birth of the universe. Yet, as this device endeavors to unveil the secrets of the cosmos, we must be mindful of the unforeseen consequences that could arise. Established in 1954, CERN is one of the globe's leading research institutions, comprising 23 member countries and a vast network of experts. It is a center of collaboration and innovation. The LHC is CERN's flagship project, but it is only part of a vast system of accelerators. This race to decode the universe's fundamental particles is like an orchestration of subatomic collisions. The LHC propels protons to speeds approaching that of light, inducing collisions that mirror the energy levels of the Big Bang. These crashes generate temperatures of millions of degrees Fahrenheit, thousands of times hotter than the core of the Sun. A complex system of magnets directs the protons on their trajectory, while advanced cooling mechanisms maintain temperatures lower than those found in outer space. The system includes 1,232 dipole magnets that bend the beams and 392 focusing quadrupole magnets that refine the beams prior to impact. More magnets compress the particles, increasing the probability of collisions. The mission of CERN necessitates extraordinary accuracy, similar to the precision required to make two needles collide from a distance of just 6 micrometers. The required precision is staggering. The technological advancements are unmatched. The LHC's design is an engineering feat featuring two parallel beam lines situated 574 feet below the surface, protected from environmental radiation. The entire system functions at an extremely cold -456 degrees Fahrenheit, colder than the vacuum of space, which is essential for the superconducting magnets to operate. Collisions in the LHC occur at 4 specific locations within the ring, corresponding to 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each detector has a unique role in probing different aspects of particle physics. Together they serve as enormous cameras, capturing images of these collisions. Researchers then analyze the data, seeking the elusive Higgs boson, also known as the God particle, a vital element in the structure of the universe. It is similar to assembling a cosmic puzzle with unknown pieces and an obscure image. Exploring the microcosm offers insights into the nature of the universe. Yet each answer and every new discovery leads to more questions and challenges. The LHC is not just a scientific apparatus. It is a tribute to human creativity, advancement, and ambition. It embodies our collective pursuit of understanding and our desire to comprehend the basic forces that shape our universe. However, as we extend the limits of our knowledge, we must also confront the existential and ethical questions that emerge. What are the risks that come with venturing into the unknown? Could our quest for knowledge unintentionally release uncontrollable forces? Within the hallowed halls of CERN, where human frontiers meet, understanding is continuously expanded. A new finding has emerged, one that disturbed even the most seasoned scientists. Brian Cox, a former CERN scientist and a prominent figure in particle physics, recently made a statement that has both intrigued and alarmed the scientific community. Cox's remarks point to a chilling possibility. The goal of CERN's Large Hadron Collider is to replicate a miniature Big Bang. Yes, you heard that correctly. A scaled-down version of the event that birthed our universe. Cox also emphasized the potential consequences of this goal, highlighting the LHC's extraordinary potential for groundbreaking discoveries. This includes its ability to reveal the secrets of the Higgs boson and explore dark matter, which makes up a substantial portion of the universe. The opportunity to glimpse the true nature of the cosmos is immense, yet fraught with peril. The miniature Big Bang is not merely a theoretical idea. It is a tangible reality within the LHC. The temperatures, pressures, and immense levels of energy resemble the conditions of the universe's earliest moments. It is like witnessing the dawn of time. But such power carries significant responsibility and the possibility of catastrophe. Imagine a situation where something goes terribly wrong. In 1978, Anatoly Bugorsky, a physicist from Russia, experienced an accident that dramatically altered his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction caused a proton beam to strike his head. The beam, moving at an unimaginable speed, was reached through his skull, entering the back of his head and exiting through his nose. Bugorsky saw a flash brighter than 1,000 suns without experiencing any pain. It caused a trail of destruction, burning tissue and bone, yet he remained conscious and even walked to the hospital for treatment. The aftermath was both horrifying and fascinating. The beam caused localized tissue damage, resulting in partial facial paralysis and hearing loss in one ear. Remarkably, Bugorsky's intellect remained intact and unaffected, and he continued his scientific work. This incident is not only a personal tragedy but also a cautionary story that shows how powerful and potentially dangerous particle accelerators are. The dangers that come with devices like the LHC should not be underestimated. The likelihood of unforeseen reactions and manipulation of the fabric of reality are genuine concerns. The universe's secrets are not mere curiosities. They are fundamental units of energy. One of the most concerning possibilities tied to the LHC's experiments is the creation of miniature versions of black holes, regions of spacetime with such intense gravitational pull that even light cannot escape. They are the universe's vacuum cleaners, devourers of stars, and mysterious entities lurking in the dark. The idea that the LHC could create such entities, even on a small scale, is alarming. Experts and laypeople alike should be concerned. If such a black hole were to grow uncontrollably, consuming the Earth from within, it would be a catastrophe of unprecedented scale. However, scientists at CERN assure us that any black holes created would be incredibly small and would vanish almost instantly. Still, the very possibility has sparked debates, fears, and awe at the power we hold. Understanding how the LHC could create a black hole requires an understanding of the fundamentals of particle physics and accelerators. When protons collide at nearly the speed of light, the energy released is so great that it distorts the spacetime fabric. Consider a tightly stretched trampoline with a massive weight dropped onto it. The surface twists and warps. When the weight is heavy enough, it could result in a depression so deep that anything nearby would be pulled into it. This analogy simplifies what could happen in the LHC. In the realm of quantum physics, where the laws of the universe are strange and extraordinary, there is a theory suggesting that hidden dimensions may exist within our reality. If these LHC collisions access real dimensions, they could tap into them, creating a gravitational well that forms a microscopic black hole. This unsettling dance of possibility and reality has captured the attention of eminent scientists. The late Stephen Hawking, in his book, warned of a scenario where the Higgs boson could become unstable at extremely high energy levels. This uncertainty has the potential to bring about catastrophic vacuum decay, a cosmic event that would not only destroy Earth but all of space and time. The distinguished British cosmologist and astrophysicist Sir Martin Rees also expressed concerns about experiments carried out at CERN. In his book, he examined the potential dangers of particle collider experiments, including those at CERN. His words were imbued with a sense of existential fear. He discussed the possible outcome where a poorly conducted experiment could start a process called vacuum instability. This uncertainty could theoretically set off a phase transition that would ripple through spacetime, potentially annihilating the entire universe. These concerns are not confined to theoretical musings. Rees devoted considerable attention to these extreme scenarios, albeit with low probability. However, even a small chance, he argued, should cause us to pause. The stakes are astronomically high, and the margin for error is razor-thin. The scientists at CERN have rigorously assessed the potential risks associated with their experiments and have implemented numerous safety measures to minimize possible threats. However, scientific exploration inherently involves a degree of uncertainty, particularly when venturing into unknown territory. The pursuit of knowledge has always carried risk. Throughout history, scientific breakthroughs have often come with unforeseen consequences. Yet it is this very willingness to push boundaries that has driven humanity forward. The LHC represents the culmination of decades of scientific progress and embodies humanity's insatiable curiosity about the cosmos. However, the potential hazards posed by experiments at the LHC cannot be dismissed. Despite the likelihood of catastrophic events being low, the consequences could be monumental. Therefore, it is vital for scientists, policymakers, and the public to engage in open discussions about the ethical and safety implications of such research. In conclusion, the Large Hadron Collider at CERN is a marvel of human ingenuity and scientific achievement. It provides unprecedented insights into the universe's fundamental nature. However, with great power comes great responsibility. It is crucial to approach this groundbreaking research with prudence and awareness of the potential risks involved. As we continue to uncover the universe's secrets, we must maintain vigilance and ensure that our pursuit of knowledge does not come at the cost of our safety and well-being. As we delve deeper into the complexities of the Hadron Collider at CERN and the scientific endeavors it represents, it becomes ever more apparent that the pursuit of knowledge is fraught with both peril and uncertainty. The Hadron Collider, with its remarkable potential for groundbreaking discoveries, stands as a monument to human brilliance and the relentless pursuit of comprehending the fundamental concepts of the universe. Yet behind the enticing exterior lies a world of significant scientific inquiry, laden with potential dangers and moral dilemmas. The experiments conducted within the collider's vast infrastructure harness energies and forces beyond the comprehension of most people. The collision of subatomic particles at nearly the speed of light creates conditions similar to those present in the earliest moments of the universe, allowing scientists to probe the very building blocks of matter and the fabric of spacetime itself. Yet, the immense energies involved in these collisions also present considerable risks, both known and unknown.